Good morning, space scientists. Today we're going to talk about the solar system, and in particular, the difference between the inner planets and the outer planets. To understand this, let's look at how the solar system began. Originally, we had a collection of gas and dust that was fairly evenly spread through this part of space. Because of gravity, these materials started to form lumps. Over more billions of years, the lumps turned into discrete balls. And because they took on a spin, they were elongated into disks, with the sun starting to form in the center and planets around it. Then, as the planets, the inner planets, started to coalesce, the sun exploded. This took out all the remaining dust and gas and flung it towards the outside of our solar system. Then, in billions more years, those remaining materials started to collect into the outer planets. Gravity is relentless. It keeps pulling things together, and soon almost all the material in the solar system formed the sun and the planets, but not all of them. In between the inner and outer planets, we have an asteroid belt that has the remainders of what may have been a planet that never formed, or a planet that was destroyed by coming into close proximity with Jupiter. This asteroid belt forms the distinction between the inner and the outer parts of our solar system. Let's look at the planets individually. Mercury, Venus, Earth, and Mars form the inner planets. And they're rather distinct. It's not hard to remember that Mars is the next planet past Earth. But Jupiter, Saturn, Uranus, and Neptune might be a little confusing because they don't have the kind of distinct looks we're used to with the inner planets. There's a mnemonic to help you remember the order of the planets. And it goes like this. My very educated mother just served us noodles. One more time. My very educated mother just served us noodles. That will give you the first letter of every planet in order, and you'll never have to guess which planet goes where after that. Now let's talk about characteristics of the individual planets. You know that the Earth has a 24-hour day, and that its year is 365 days long. Well, how does that compare with other planets? As it turns out, Mercury and Venus are spinning much slower. Both of them take many days to complete a revolution that we would call one day. Mars, on the other hand, is very similar in its day to Earth. But look at the outer planets. 10 hours, 11 hours, 17 hours, 16 hours. These huge outer planets are spinning very, very fast. And just because they take half the time to form a day doesn't tell the whole story. Because their diameter is much bigger than Earth, their surface is whirling many times faster. Now let's talk about years. Mercury goes around the sun in less than a month. Its orbit is very fast. Venus, 225 days, has a year that's comparable to Earth. Mars takes almost 2 years, 2 Earth years, to complete one of its yearly revolutions around the sun. But look at the outer planets. 4,000 days to get around the sun for Jupiter. Close to 11,000, 30,000, and 60,000 days for Neptune to go around the sun. Now, obviously, their path through the solar system is much, much longer than ours. So, is their year so long because it has to travel that far, or are they going slower? It turns out both. They do have an extremely long distance to travel, and they tend to be going a lot slower. Let's look at the speeds. Mercury, over 100,000 miles per hour in its orbit. Venus, 78,000. And while you thought that you were just going to the beach, each of us is traveling 67,000 miles per hour all the time as the Earth takes us around the sun. 67,000 miles an hour while we're standing here thinking we're standing still. Mars is a little less. But you'll see that the outer planets are very, very much slower. 29,000, 22, 15, 12,000 miles per hour. Obviously, that's an enormous speed. But in terms of planetary mechanics, the outer planets are slowpokes. Okay? We tend to be in the middle. Mercury's faster, the outer planets much, much slower in their path through space. Now, I want to know what you've learned about Earth that makes it the only place life has ever been discovered. Read your Discovery Education, sections 1.3, 1.4, and 1.5. They will give you a lot of information about the distinction that Earth has. And then write a paragraph describing what you learned about why life exists on Earth and, to our knowledge, nowhere else in the universe. Learn a lot. I'll see you next time.